big five. So we're talking about uniform acceleration. Whenever an object is accelerating at a uniform rate, i.e. its acceleration is not changing, we have 5 equations that we have to deal with. Before we talk about that though, I just want to make sure we understand there's only 5 variables involved in the big five. We've got obviously the acceleration, the initial velocity v1, the final velocity v2, the displacement delta d, and the time interval delta t. It's important to understand obviously that the velocity is changing if you're accelerating. That's pretty straightforward. And this d is the displacement, not the distance. It's how far you actually are from where you started. And it's the displacement which happened during the time interval delta t. So the big five are written here. Hopefully by now you have seen them. There are 5 equations. Of the 5 variables, you'll note that each equation has only 4 variables. What that means is that in order for you to get anywhere, you need to know at least 3. Because if you know 3 things, then you can always find any fourth using any one of the 5 equations. So if you don't have 3 pieces of information at the start of a problem, once you've written down your givens, then you're probably reading the question wrong. Or the question is actually impossible or something. Anything else I should add, Mr. Caruana?
Why don't you solve a problem?
Okay, I will solve a problem. Here we have a conveniently located problem on the board. A car accelerates at 3 meters per second squared from rest for 10 seconds. How far does it travel? Now, the obvious question is, which big five formula do we have to use? The simplest way to discover that is to write down all 5 of your givens every time, no matter what. So, let's go through that. A car accelerates at 3 meters per second squared. Clearly, A equals 3 meters per second squared. Technically, these are vectors, so let me call that positive forward. V1, it starts from rest, so V1 is 0. What is its final velocity? We don't know. How far does it travel? We don't know. And how long does it take? 10 seconds. So clearly, I've got 3 things. I don't know V2 or D, but I am trying to find the distance, or the displacement D. I don't know anything about V2, and I don't care. So what I want to do is look at my big five and find the one that doesn't have V2 in it. That is this one right here. Equation number 3 does not have V2. Just like equation number 1 does not have A. Equation number 2 does not have D. Equation number 4 does not have V1. And equation number 5 does not have time. So each equation is missing one variable. Determine what variable you are missing, and then you know which equation to use. In this case, it's equation 3. D equals V1t plus half AT squared. Substituting in my values, I'm always, of course, going to have units, at least on my first line. I've got to make sure the units are the same. All meters and seconds, no kilometers, no hours, no minutes. Delta D equals V1, which is 0, so who cares what t is, plus a half, 3 meters per second squared times the time, which is 10 seconds squared. So 100 times a half is 50, times 3 is 150. The displacement will be 150 meters, which means the car, since it's going straight, it's not turning around or anything, the distance it travels and the displacement are both 150. Therefore, the car travels 150 meters. Easy.